alignment profiles. I mean, how you visualize it, basically, that's what I'm trying to say. Yeah. So, see, I myself I proved myself wrong. I said, okay, SSS is one case. Then I said, okay, SAS also applies. Now, I'm saying that, okay, the third theorem also applies.
Yes, sir, yeah.
Yeah, because we could prove the two angles and the side between them. So basically, anything and everything that applies for a regular triangle applies here.
Okay, yeah, got it.
All right. So we saw the area of rectangle, area of a triangle, area of a right angle triangle basically, not area of a triangle. Yeah.
Yeah.
Now, okay. But area of any triangle, area of any triangle, how is that half times base times height?
That's because triangle is a half of a rectangle.
That is visually more appealing when we look at this as a
Right angle.
right angle triangle. I'm not looking at a right angle triangle right now. Then how do we prove it? Right? Yeah. So let's do one thing. Now I'll make it little. It might look a little difficult to begin with, but I'll keep breaking it down. Let's say this is my triangle. Okay. What will I do?
Oh, yeah. So
Yeah.
the exterior, the area outside the triangle, if you add them together, that also equals a triangle.
Yep. Okay. This was my triangle. Okay. What did I do? I took the two vertex and have drawn a perpendicular on the line that is crossing this one. So basically, if you look at this, I have three triangles here, and which is adding up to make the rectangle, right? Now, what you can do is from here draw another perpendicular line. Okay? So, what happens is this becomes your right angle triangle, this is your other right angle triangle. Okay? Look at the blue piece. Okay? And then look at the green piece. Okay? So in the blue piece, this was my triangle for which I was trying to find out the area. What did I do? I have just drawn perpendicular lines and joined them together, so this became my rectangle. If I had to find out the area of the rectangle, that would have been base times height. Okay? But I'm trying to find out the area of this triangle. Now look at this carefully. If you look at this piece alone, this is one right angle triangle, this is another right angle triangle because we have drawn perpendiculars, right? So
Yeah.
this will be same as this, both are 90 degree. Hypotenuse is same and height is same, right? So this part of the area is equal to this part of the area. Similarly, this part of the area will be equal to this part of the area. So net what we are seeing is this triangle is comprising. So basically, this side of the area is equal to this side. This area is this area. Basically, inside the area inside the triangle is same as area outside the triangle, which is making the rectangle. Making sense?
Yeah.
So that is how you will say, okay, fine. So this area is half of the area of the rectangle, which is half times base times height. So you can always visualize that if you have a triangle, you can extend the corners in the perpendicular direction, okay, and join them together. That makes the area 2 times of the area of the triangle, which converts into a rectangle. Look at a possible weird triangle, okay, and you will see that also becomes a rectangle. Let's say I'm talking about this This is a scalene triangle, right? Not a very normal scenario.
Scalene or what? What?
Scalene, right? All sides are different.
Yeah, sure, yeah.
So same thing. If I just extend the corners in a perpendicular direction, this makes it a rectangle. And same thing, if you draw perpendicular from here, now you have two right angle triangles here, two right angle triangles here. This triangle's area is equal to this triangle's area because they are congruent. You can always prove them congruent, right? Like your hypotenuse is the same and height is anyway the same. Yeah?
Can you repeat that? My mind went blank, I'm sorry.
No, that's okay. No, I was trying, see, whatever we did, I'm doing the same thing with a very weird example. Weird is something that is not very normal to see. Yeah, scalene triangle, right?
Yeah.
And what I was saying was, whenever you have to visualize the area of the triangle, I'm saying area of the triangle is half times base times height. I'm just trying to see if that is the case for any kind of triangle or not. So we took the scalene triangle, the vertex we had drawn perpendicular and we joined them.
Oh, yeah. Yeah.
You will see from here so now you have split this into two pair of triangles. This triangle is congruent with this one because the hypotenuse is common, height is same. Similarly, if you look at these two tiny triangles, they also both are right angle triangles and the hypotenuse is common and height is the same. So basically, this triangle's area is equal to this area plus this area. Yeah?
Yeah.
So that is how area of a triangle is half times base times height for any and every triangle. If it's a right angle triangle, it's easy to see. Otherwise also, you have any triangle, pick up the base, look at the height, multiply that by half. Yeah? So,
Got it.
after today's class, you will not say that my teacher has not told me how the area is derived, how the formula is derived, right?
Yeah, of course.
Yeah. No, I mean, why I'm saying so because it's very important for us to understand the origination of those formulas because that helps you build a concept around it.
Yeah, I get it. Yeah, I get it.
If I say, okay, area of a rectangle, length times width, area of a square, length times length, area of a triangle, half times base times height. I would have finished this class in 5 minutes. But then the ability to retain that information would have been less compared to what we did so far. Yeah? Now, what's the time right now? I know. Okay, we have 15 more minutes. Let's do one other one, which is trapezoid. Do you want to do trapezoid? Okay. No, let's not do trapezoid. So we did rectangle, we did square. Let's go to a step brother of square that is called rhombus. Yeah. This is a square step brother. That's what I call it.
Skip what?
Step brother.
Oh.
You would have seen in Indian movies, right? When the stepchild is not treated well. So the square was not treated well. Somebody was squeezing it, pressurizing it. That's how it became a rhombus. Meaning the sides remain the same, but the angles changed. Like if a child gets a lot of beating, you'll get some damage, right? So that damage happened. The angles changed.
Suppressed.
Yeah, suppressed. Yeah, child is suppressed. That's a better word. Yeah. So here, when we looked at the property, do you remember what did I say? These diagonals. These are diagonals and they are perpendicular bisector of each other, meaning they meet at 90 degree and they divide each other into half.
Yeah.
This will be equal to this and this will be equal to this. So you see the number of lines that I am putting here, right? So this is 3, this is 3, this is 1, this is 1. So they are same. This is 2, 2, 2, 2. All four sides are same. Yeah?
Yeah.
Now you look at this triangle and this triangle. What do you see? They are congruent, aren't they?
Mm-hmm.
Because both are right angle triangles.
Yeah.
Hypotenuse has same length. This side is common. What else do you need? It's congruent. Yeah? Make sense?
So you just now told me that two of those triangles are congruent, right?
Yes. Let's say
Yeah.
A, B, C, D and they are meeting at O. Now what I'm saying is triangle A, B, O, O is the center, and triangle A, D, O are congruent. Agreeable?
Yes.
Now look at this triangle and this triangle, meaning triangle BCO and triangle COD, meaning bottom two triangles. They are also congruent. Why? Because hypotenuse is same, length of the sides are same, and this is common. RHS. Yeah. Now look at triangle AOD. This one and this one. Triangle AOD and triangle COD. I'm looking at this triangle and this triangle now. I'm saying these two are also congruent. Why? Because hypotenuse is same, this side is common. Yeah? Essentially what we are seeing here is when you have a rhombus, the diagonals split them into 4 equal right angle triangles. This is congruent with this one, so this area same. This is congruent with this one, so this area same. And this is also congruent with this one, so this area also same. Yeah? So I can say area of rhombus equals 4 times area of any of the triangle, let's say AOD. Yeah. Now AOD is what? AOD is nothing but a right angle triangle. Yeah. So 4 times area of AOD, half times base. Base is OD. Okay. And height is AO. Yeah. Half times base times height, OD into AO. Yeah. So now this becomes, if I bring this here, it becomes 2 2s are 4. So 2 times OD into AO. Okay. Now what is OD? OD is half of the diagonal. Let's say if we call this diagonal 1 and this is diagonal 2, OD is what? Half of diagonal 2.
Yeah.
Because the diagonals bisect each other perpendicularly. So OD is half of diagonal 2. Similarly, AO is what? AO is half of diagonal 1. Half of diagonal 1. Yeah?
True.
Do tic-tac-toe.
Tic-tac-toe.
So what it becomes? Half into D1 into D2. Okay? So,
yeah.
So what it means is, area of a rhombus is half into diagonal 1 into diagonal 2. That's it.
I get it. Yeah. Makes sense.
So we looked at area of a rectangle, area of a square, area of a triangle, area of any kind of triangle, area of right angle triangle and area of rhombus. That is more than enough.